Okay, so we got this situation in which we have to handle line and the hyperbola. You know that you have handled this situation in so many times. Means you have handled it in circle with line, parabola with line, ellipse with line. Now you have to handle this situation with hyperbola as well. You also know that we have connected the condition for tangency. Tangency means straight line should touch the curve only once. Okay, now we will do the same over here as well. You also know that we have connected lots of concepts from ellipse with hyperbola, correct? So if you remember the condition for tangency in ellipse, you will get c square as a square m square plus b square. Hope you remember. If not, then you can go and again go through your notes, and if you want you can go through the video lecture as well. Okay, now suppose that this is the condition of tangency in hyperbola, sorry, ellipse. So you know that for hyperbola we just replace b square with minus b square of ellipse and things are done. So hopefully we will get this as the condition of tangency in hyperbola case. Okay, now let's try to solve this situation. So what we will do, we will require a straight line. So can I go through y equals to mx plus c, and we will get hyperbola equation, that is x square by a square minus y square by b square equals 1. Now what we have to do, we have to substitute this in this equation and then put d equals to 0. Things are done. So we will do the same over here. Let's simplify this curve first. Can I multiply both sides by a square b square? After multiplying, we will get b square x square minus a square y square minus a square b square equals to 0. Correct or wrong? Yes, good. Now, can I replace this y with this y? We are following substitution method. Okay, so we will get b square x square minus a square mx plus c whole square minus a square b square equals to 0. Now let's open this bracket. We will get b square x square minus a square m square x square c square plus 2mcx minus a square b square equals to 0. Now let's write down this equation in standard form, means leading will be x square, then x, and then constant part. So I'll be writing x square first. So we get b square minus a square m square x square. Now we will go through the x. You know that we will have x only in this situation, correct? So we will write down those things as well. So 2 a square mc x. Now we will write constant. So you will have constant from here and here only, correct? So both way minus, and also we have a square common. So can I write a square with c square plus b square common? Just tell me. Now if you will observe, we got quadratic in x, correct? Now for condition of tangency, what we used to do? Exactly, d should be 0. So b square 4 a power 4 m square c square b square minus 4, this minus, acha, we'll write a first. B square minus 4a, b square minus a square m square, and then c, this is minus, so minus minus plus, we have a square c square plus b square equals to 0, correct? Now can I divide both sides by 4 because I am having both things common and 4 is a positive number, so it's okay. Done, done. Now look at this. We have a power 2, a power 4. Can I divide both sides by a square? Because we know that a square cannot be 0. So it's a positive number. We can divide both sides by a positive number. Okay. So this thing gone. We are left with a square. So we got a square m square c square. Now let's open this bracket. Plus b square c square plus b power 4 minus a square c square m square minus a square b square m square equals to 0. Now look at this. A square m square c, a square m square c square. This thing gone. Now can I divide both sides by b square? Because here also b square, here also b square, and here also b square. And you know that b square cannot be 0. So you can divide. So we will have b square plus c square minus a square m square equals to 0. Now if you will write in this part, so you have to write c square is equal to a square m square minus b square. So what we were assuming, we got the same thing. I hope the idea is clear. You have to follow the same approach. Okay.